Hello everyone, it's my pleasure to introduce our work on PrivateX, a privacy enhancement technology for conducting exchange on blockchain. My name is Lei Xu and I work at the University of Texas, Rio Grande Valley. This is a joint work with Lin, Kevin, Kishaf, Miguel, who is an undergraduate student of UTRGV, Bogdan, and Larry. My presentation is divided into 4 parts. We first introduce the background information and explain why we want to study this problem. We then give more details on the problem and highlight the challenges. In the third part, I will provide the key ideas in the design of PrivateX. And I will conclude the talk by discussing potential extensions of the current work. Bitcoin is probably the first cryptocurrency that is widely adopted. A large number of cryptocurrency, digital currency, or e-cash schemes were developed before Bitcoin, but none of them was widely accepted. While there are many potential reasons for this, personally, I believe one major cause is that all these schemes rely on a centralized party, which is usually the bank, and the bank doesn't have any incentive to adopt such technology. Bitcoin finds a way to get around this dependency by using the blockchain as the backbone to support both transaction and creation of cryptocurrency. In a nutshell, a blockchain is a data structure maintained by multiple parties through a consensus mechanism. The concept of cryptocurrency is then extended to crypto asset. In theory, anything can be converted to a crypto asset and then the ownership can be changed in the cyber world through a blockchain system to enjoy all the benefits such as efficiency and decentralization. How to convert a physical asset to a digital asset managed by a blockchain system is also an interesting question, but it's outside the scope of this work. The best strategy to guarantee the correctness of records is to allow everyone to be able to verify it. This is exactly what the Bitcoin system does. Another critical assumption is that the majority of the participants are honest. Otherwise, there's no way for us to guarantee the correctness. The success of Bitcoin has proved the effectiveness of this strategy. However, this strategy is a two-edged sword and also brings new privacy concerns. While the Bitcoin system gives users a feeling of privacy or anonymity, a lot of works have shown that the real situation is not the case. To mitigate the privacy issue of blockchain-based cryptocurrency systems, several techniques are developed. The first one is integrating MixNet with a blockchain-based cryptocurrency system. This scheme requires some trusted or at least semi-trusted nodes to work as proxies to mix all transactions to hide the real transaction from the public. Another approach is hiding one real transaction within a group of hiding transactions. It can achieve a certain level of anonymity, but requires the users to be careful enough to avoid correlation analysis. The last approach is privacy-preserving statement verification, which is usually implemented using zero-knowledge proof technology. Until now, this looks to be the most promising approach and provides a better privacy protection compared with the other two approaches. However, most of these works focus on the protection of a cryptocurrency system and didn't consider the case there are more than one type of asset in the system and there's a need of exchanging different types of assets. Here, exchange means two users swap their ownership of crypto assets. Exchange of assets only makes sense when there are at least two types of assets in the system. Otherwise, it's meaningless. For instance, it's common for people to exchange different currencies, but it doesn't make sense for people to exchange €1 for another €1 with another person. Currently, there are mainly two ways to support exchange. The first way is to use a centralized exchange platform, and there are a lot of such platforms in the market. The second way is to use a blockchain-based smart contract system. In fact, Ethereum can be treated as such an exchange platform, where users can exchange different types of tokens with the help of smart contract. However, smart contract itself doesn't provide any privacy-preserving capability. It still relies on the information openness to guarantee the correctness of smart contract execution results. So a natural question to ask is whether we can build a blockchain-based exchange platform that is privacy-friendly. In this work, we provide a positive answer to this question. Without loss of generality, we assume two users, Alice and Bob, have two different types of crypto assets, and they want to exchange with each other. This figure demonstrates the major steps of the exchange process. Both Alice and Bob first convert their own assets to the form of notes, which are the basic operation unit for our private X. Assume Alice is the one who initializes the exchange. She will put information of her desired asset into the newly created note. Bob can then finish his step to obtain Alice's asset by creating a new note and consuming his own note. After Bob finishes, Alice can create a new note for herself that represents Bob's asset to finish the exchange. Private X also supports when to terminate the exchange as long as it's fair for both involved participants. While this process looks to be straightforward, it needs to satisfy several requirements, and it's not that simple. Let's discuss the requirement in more details. The first requirement is correctness. These are the very basic requirements. For example, a user can only use his or her own asset for exchange, and can't create new asset from scratch. A user also can't change the asset information in the process of the exchange. The second requirement is fairness. Fairness requires that the exchange operation only has two possibilities: success or fail. If the exchange succeeds, both parties get each other's asset. If it fails, each party can get his or her own asset back. The last but not least requirement is privacy. Intuitively, it requires that one can only learn information of an exchange that he or she is involved. This feature can be captured by the indistinguishability of the blockchain, which we discussed in the paper. Next, we briefly discuss how the design of private X meets all these requirements. Note that we always assume the blockchain as a whole is honest but curious, which means the blockchain will follow the protocol and enforce the protocol, but all participants of the system will try to figure out as much information as possible. The correctness feature is achieved by the consensus mechanism of the blockchain. Similar to other blockchain-based cryptocurrency or crypto asset system, the creation of new node always consumes an old one. If one tries to use the same node twice, the blockchain will detect and prevent it. The blockchain can offer a total order of received transactions, and this feature is utilized by private X to guarantee fairness. Alice and Bob submit a sequence of transactions to the blockchain to finish the exchange process. Assume Alice is the one who initializes the exchange process. She will create a node with two parts of information: her own asset and the asset she wants to get from the exchange. Bob also creates nodes for his own asset, and he can consume both his and Alice's nodes to create a new node standing for Alice's asset. But this node belongs to Bob right now, and only Bob can consume or span this new node. After Alice's node is consumed, Alice can create a new node by herself, which stands for Bob's asset. This finishes the exchange process. As mentioned earlier, private X aims to provide more flexibility if it doesn't compromise the key requirements. Therefore, a participant can change his or her mind in the process of exchange as long as it doesn't affect others. Privacy is a major design goal of private X. Private X utilizes zk-SNARK, a special type of zero-knowledge proof technique to achieve privacy-preserving verification of transactions. The most challenging part is that Alice and Bob finish the exchange in a sequential manner, so one must go first and give his or her asset before getting the other's asset. Private X embeds two tags instead of one to a node for exchange. These two tags serve different purposes. One is shared with the other party to facilitate the exchange, and one is used by the node creator him or herself to complete the transaction. The second tag can also be utilized to terminate the exchange if the first tag is not consumed. The way to prove the knowledge of the tag is done using zk-SNARK, which is similar to the popular Zcash system. zk-SNARK is also used to verify other features of the exchange, such as that the two nodes can match with each other. In summary, Private X provides a good start point on building a privacy-friendly blockchain-based exchange platform. There are several things can be considered to further improve such a system. The first is how to port crypto assets to different blockchains. To fully unleash the potential of Private X, we need a large number of assets to be exchanged on the same platform. Therefore, the porting technology will be critical. The second direction is more efficient zero-knowledge proof system for exchange. the current ZK SNARK is not very efficient from a computation perspective. The last direction we are considering is to support exchange between more than two parties. Although it's straightforward to implement multi-party exchange with a sequence of two-party exchanges, the atomic feature is not guaranteed, which means one can stop the whole process before the exchange completes. That's all for my presentation. If you have any questions or just want to have research discussions, please feel free to drop me a message and I will be more than happy to answer or have an online meeting with you. Thanks for your attention and stay safe.